Hello, welcome back to the channel. Today we're going to be talking about this computer. Not specifically about this computer, but the things we're going to put inside this computer. So in a previous video I've said that the Amstrad PC1512 was my favourite computer of the 20th century, and I stand by that. It is a great computer. So you have one of these at the time, you probably would have done some upgrades. This one's had a 3.5-inch drive installed instead of 5.25. The one I had, I bought a hard card for it, and that made these much more functional. So what about now in 2024? Is there any other upgrades you do to this computer? Well, yes there is. I'm going to be talking about the PicoMEM by FreddyV. So first of all, let's go back to the upgrades. So this one's got a 720K floppy drive, and that's the maximum that this floppy disk drive controller can take. It won't take 1.44 megabyte drives, it's just not fast enough. But we could definitely consider upgrading a hard card in here. So a hard card is basically a hard drive and a hard drive controller on an ISA backplane. So this plugs into one of the available slots in the back of your PC or your PC XT, and that gives it hard disk space. So this is a 20 megabyte one, I think, from memory, as a Western Digital mega card. This one doesn't work, unfortunately, but that's definitely one thing you'd want to consider adding. If you played games on here, you'd probably want to add something like this. So this is a joystick port. This is a dual joystick port, and if you're interested in playing games, you might want to add one of these so you can add in a joystick. But playing games with a computer that's only got a PC speaker is not that much fun. So the other thing you do is you probably add a sound card. This is a 16-bit sound card, so this isn't going to fit in my system because it only has 8-bit slots. It does have a joystick port though, so you could kill two birds with one stone here by adding in a sound card. So you've added a hard disk, you've had some fun adding a sound card. Getting things on and off this computer is a bit of a pain. Making 720K disks is a bit troublesome. Making 1.44 megabyte disks would be a lot easier. So is there any way I can fit a 1.44 megabyte drive in here? Not straight away, but we'll come to that. But if you can't add a floppy disk, how about just sticking it on the network using a network card? Again, this is 16-bit, so it's not going to fit in my particular system, but 8-bit ISA cards are available. So we can just copy things across over the network. Why don't we just do that? Good idea. Problems, we'll come to those in a bit. And what about memory? This has only got 512K of memory. A lot of software required the full 640K with as much free as possible. So memory upgrades are a big help, and that can be either by upgrading RAM chips on the board to take this to the full 640K, doesn't take a megabyte, or you could add an extended or an expanded memory card and take it above 1 megabyte. Again, there are some troubles doing this. So the biggest problem with adding all these things in is how many slots have you got? How many ISA slots have you got in the back of your machine? Can you actually fit them in? For example, the hard card, that takes up 2 slots. You can get away with not having the joystick port if you're using a sound card, that's another slot. Network card's another slot, so that's 4 slots. Expanded memory, that's 5 slots. So why is that a problem? Well, this computer's only got 3 8-bit ISA slots, so I can't put all of these options in one go. Are there any modern equivalents that can help us? Well, yes. For several years I've been using an XT IDE. So this is a new, as in this is a 21st century device that someone dreamt up, and it has an XT BIOS IDE chipset, and you can connect IDE drives to these. This is a cut down version that only takes compact flash cards. They just slot in the end here. So this works really well in this PC1512. But can we do even better than this? That solves one of our problems, the hard card, and it only takes up about a quarter of a slot, not a whole slot. So can we do even better than this? Well, yes, we can. So FreddyV has come up with this, the PicoMEM, and there's a few things that are interesting about this. The first one is that it's essentially a software-defined card. So on here, there's no IDE adapter, there's no network chip, but what on here is a Raspberry Pi Pico, and that, in software, emulates all the functions of all the devices I've just shown you. That's pretty amazing. It does require this daughter card here if you want to do sound, and we'll come to that in a bit. But basically, this small card can replace all the functions of the things I've just shown you, and it has some good tricks up its sleeve as well. In terms of storage, we have a micro SD card slot here, and you pop in there a pre-formatted card, and on that you have images and configuration files, and those images can be floppy disks or hard disks. So we can put a hard card equivalent in here, and it takes floppy disk images too. So we can actually have 144K images in our machine that doesn't support them. Also, here is a micro SD connector, and with this, if you have an on-the-go connector, we can connect to various different peripherals. Currently supported is mice and gamepads. More will be supported, such as keyboards in the future. Down here is a quick connect connector as well, and this allows you to connect a small display which can display BIOS error codes. So that's another card I haven't shown you because I haven't got one working at the moment. But basically you can do diagnostics on the machine that doesn't boot by looking at what's happening on the ISA bus, and this card allows you to do that as well. In terms of installing it, it's dead easy. You just select what IRQ you want it to have. It defaults to 7, and you just pop it in a spare ISA slot. This particular one came pre-assembled, including the audio digital analog converter, and that's what this little daughter board is here. And with this in place, there's a little 3.5mm jack on the top, and the software that's running on this little Raspberry Pi down here can emulate a AdLib sound card as well as doing all the other things it's doing. So the little microcontroller that runs this Pi Pico here, I think runs by default at 125 megahertz, but I think it's been overclocked to enable it to do all of these functions. But in my testing so far, it's been extremely stable. I haven't found anything that it won't do. I had a couple of random problems with boots, and I think that might be because I didn't have the card fully inserted. But otherwise, it's been very, very stable. So what we're going to do is we're going to move all these other cards out of the way. We're going to install this into my Amstrad PC, and I'll show you what it can do. So these first generation Amstrad PCs are incredibly easy to get into in terms of adding things into the ISA slots. You just press down on these two tabs here, this slides off, and out comes this bit of plastic that we often refer to as the sunroof. Then you've got access to the 3 ISA slots here, and then there's a side panel that slips off as well in case you have any cards that require cables going in the end, such as sound cards or network cards. So here's the PicoMEM. We're going to put this in the middle slot for no particular reason, and it literally just goes in. Simple as that. Outside here we can access the micro SD card, so we don't even need to take it apart again if you want to update this machine. We can do all that through the side access. So I'm not going to put the top on, and the reason for that is that the audio jack that comes out of this card comes out the top. I don't currently have a right angle connector, so if I put something in there, it sticks out through the surface. So I'm going to leave the sunroof off, and I'm going to order a right angle connector. You can put the side back on if you want to, but we don't need to do that either because we want to access the SD card occasionally. Okay, so let's turn this on and see what it does when we boot it up. So I haven't got any batteries in here, so it's going to complain about that. You'll hear some beeps. So checking the RAM at the moment, but the next screen is interesting. So we get a PicoMEM BIOS message, and if we press S, we're actually into a BIOS. So it's not a true BIOS, this is software running on the PicoMEM, don't forget, but we have a very kind of familiar looking BIOS screen to what we would expect from anything from the kind of 1990s through to the, you know, mid-noughties. So this is a really welcome feature of this card. It actually gives you direct access to some of the features from pseudo BIOS. You don't have to go around playing with configuration settings on the memory card. You can do it directly from this screen. Okay, so basically it's given us a quick summary of the build of the PicoMEM. It's given us a quick summary of the computer. 512K RAM, 2 floppy drive, which is correct. No hard drives, which is also correct. And the PicoMEM is using RQ7, which is set by that jumper on the board. You can have a fast boot option. I've not turned this on yet. The boot screen that comes up goes pretty quick anyway, so I don't feel the need to go any quicker, and I want time to be able to press the S key if I need to. Now, moving along, this is one of the very interesting features of the PicoMEM. okay, is it can use the memory on the PicoMEM and an additional RAM chip to supplement the memory in your PC XT. Okay, and here it's giving you a little bit of a memory map showing you what's going on. So across the top here, we've got the full 1 megabyte of RAM that a standard IBM PC can access. Okay, so this will be the 640 of conventional memory, and then this is your upper memory. And what it's doing is showing you that there's S's here for standard RAM, and this has got 512K of standard RAM, not 640, which is why there's these gaps here. Okay, we then have the upper memory described. Okay, so we've got video ROM up here. We've got the standard PC ROM up at the very top of the memory, and then we've got some gaps. And there's a little key down here to tell you what this all means. System RAM, video RAM, and ROMs. Okay, so the video ROM here is for the built-in Paradise CGA chipset. And these are all blanked out because it has memory that it uses for its frame buffer. Okay, but there's a gap here and there's a gap here. And the PicoMEM has some very clever features about how we can fill this memory using the memory from the microcontroller and that supplementary RAM chip. For a computer like this has only got 512K of RAM, one of the best features is the PM RAM extension option. So PM is PicoMEM, RAM extension is currently off. If I turn it on, have a look and see what happens. So the remainder of the conventional RAM up to the 640 has now been filled with memory. And the clever bit about this is it's using half of the memory that's available on the PicoMEM microcontroller itself, about 120, well, exactly 128K of the 256K that's available. And the beauty of that is that runs at the full speed of the Isobus. Okay, so this is nearly as fast, if not as fast, as memory if you put memory chips on the motherboard. So what you're able to do is get 640K of conventional memory using this machine, using this card. That is absolutely brilliant. But there's more. What you can do is you can have EMS memory. So EMS is expanded memory. And basically what that does, if we turn it on, so I've turned it on and it's asked for an EMS port and address. And what it's done is it's put a 64K block of memory up here for the EMS memory driver to use. And basically that will switch out up to 4 megabytes of additional EMS memory into this space. And that's how EMS memory works. LIM, the Lotus Intel Microsoft expanded memory specification from way back in the day, driven a lot by Lotus because they needed more memory to store bigger and bigger spreadsheets. And what they came up with is this way of putting a small amount of conventional memory up in the high memory area and then just paging it out. And you can buy cards like the one I showed you earlier on that allow you to have 1 to 4 megabytes of memory. I think you can have up to 32 megs in the specification. In this particular implementation, we can use 4 megabytes of expanded memory donated by the PicoMEM. So this 512K machine has now got a full 640K of fast RAM, and then it's got the expanded memory of up to 4 megabytes. Let me just turn that off for a moment. I want to show you one other feature. I'll turn this off as well. So say you had an IBM PC that only had 128K. If you donate 128K from the PicoMEM itself, you're only going to get 256K of memory, conventional memory. So how are you going to fill the rest? Well, we're allowed to do that with this PS RAM extension option. So if we do that, okay, all the remainder of memory is filled up. It's as if the machine has 1 megabytes of memory on the motherboard. Now there are a few advantages to this. One is if you've got a very small amount of conventional memory built into the motherboard, you can fill the whole space up using this option. You've also filled up all of the upper memory areas as well, so that if you have the appropriate driver, you can start loading things up into high memory. Okay, you can't normally do that on this machine. Now, there is a penalty for that. Currently, because that's all emulated in software, And because it's memory that's not on board to the microcontroller itself, it's on a separate chip on the card, that does incur some wait states. And at the moment, the equivalent is about 6 wait states. So this memory that we've just turned on here is quite a lot slower than the memory that's on the motherboard of this computer, or the memory that's donated when we use the PicoMEM extension option. So depending on your system, you may choose to have one or both of these in effect. What I'm going to do is turn this off for this machine. I'm going to use the 128K of fast memory, and we're going to turn on the extended memory as well. I'm using the default values here, and we'll see if the driver can recognize those. So this is an amazing way of supplementing the memory on your PC. Very, 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 very convenient. You don't have to worry about duff memory chips or anything like that. The memory that's in the microcontroller is almost certainly going to be far superior to the memory that you buy that's 40 years old. You can tell it to do some other options here with the memory. So we can tell it to not preserve the video memory area. We don't want to do that. The maximize conventional memory option, I think, is for systems where there isn't as much video RAM as there is in this particular one. I think if you tick this and turn it on, I think some of this area here is used as well. So I think you can have up to 768K of memory free on this machine, depending on how much memory you've got configured and where the video RAM is. I haven't played with this option very much yet, so I don't know that much about it. In theory, there's also space here for 2 ROM files, which are represented here on the memory map up here. This is not yet implemented, but in theory, you could, for example, have a basic ROM loaded, and you can run straight to basic instead of the DOS prompt. Very, very interesting to see what people can do with this. Moving on to the next screen. So we've got disks. Now this is the next most important thing for this. So this is the replacement for your XT IDE type device. Okay, but it has much more flexibility. First of all, because we can emulate floppy disk drives, not just hard drives. Now, the way the system works is great. You can emulate up to 2 drives. Okay, now this machine already has 2 drives in it, but what this does, it kind of, once the machine's booted, it overrides and interrupts any access to these physical drives and sends them to these virtual drives. Now you can disable this when the machine boots. There's an option for dealing with that, which I'll try and demonstrate if I remember. But basically you have 2 virtual drives that you can add in images, and those images can be 1.44 megabytes or 720. They can even be 360 if you want. Okay, so there's a massive amount of flexibility here. And because you've got options 2, you can have those kind of programs where you have the system, operating system in one disk and the application itself, and then you have your data on the other one. So lots of flexibility having 2 emulated disks. Immediately underneath that, you've got 4 emulated hard drives. 4, read it and weep. So this is a great feature. So basically, currently I've got 2 drives set up. So drive 0, which represents to DOS's drive C, is configured as a 200 megabyte image. And underneath that, there's drive, a second one, which defaults to drive D, which is also 200 megabytes. Okay. Now you can have very large partitions, depending on what DOS you're using. But don't forget, on an XT class machine, which is running at 4.77 or 8 megahertz, when it starts counting up things like file allocation table spaces, it takes a long time. And you'll see that when we do the first directory, that it shows the directory, and then there's a definite pause before it shows you how much disk-free space there is. So when you're making files for this, you don't want to go too big on an XT. It's just a little bit too slow. Although the actual physical limit on the card is quite big. I think, you know, it's several gigabytes. You can have 4 drives, and not only can you have 4 drives, you can actually create them from within this BIOS. So you don't even have to take the card out to create a new image. That is an amazing feature. Brilliant. PicoMEM boot code, so you need this on if you've got no other hard disk controller in your machine, because otherwise you won't be able to boot from the hard drive. It'll still be able to boot from the floppy, but you need this to be able to boot from the hard drive. So creating a new disk image, very straightforward. How big? Well, let's make it 100 megabytes. And then we're going to call it small. Okay, so it's going to create it. Depending on how fast your SD card is, will make a difference to how quickly this will get generated. The card that I've got in here is a particularly slow card. I felt it was most appropriate for the machine. It's not going to give it any kind of weird performance advantage. I gave it a card that I thought seemed more appropriate for the hard disk speeds of the time. If you use a faster card, you'll get a faster disk image creation. Okay, that image is now created. So if we go up to a spare hard drive, for example, we can list the drive images that are available on this SD card. We created a new one called small. We'll just load that. And there we have 100 megabyte new hard drive, drive E it will appear as when we get into DOS. Okay, and so basically you can change these. So this is the default image that comes from FreddyV. It's a DOS 3.31 English 200 megabyte drive image with some tools on it that are useful for configuring some of the other features that we'll see in a minute. But you can create your own, and you can even image a real hard drive and put that image on this SD card. You can use that immediately. Very, 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 very good. Very convenient. So I'm just going to turn off small for now because we don't need him. So that's disk images, both floppy and hard drive. Brilliant features. Audio. So this is a new feature, a relatively new feature. So on the card that I ordered, and I ordered mine pre-assembled, I also have the optional digital to analog converter board added, and that gets soldered on the top of the card. And then there's a 3.5mm jack that goes in that. And if you have that card, you have the option, this audio option on the menu, and you can turn on the audio features. And there's not a lot to see on the screen, but basically what you're getting is AdLib compatible sound card coming out of this machine as well. All on the same card, nothing extra apart from that daughter card, which only costs a few dollars. Now my particular one is very noisy. I've changed my audio cable just now. Literally, I haven't used it before, so we're going to find out if it's any good. So it'll be interesting to know whether I've got a defective card or whether they're all quite noisy. That's the only downside I found to this whole card so far. What else can you do? Well, this is where it gets really clever. My Wi-Fi text configuration file is obviously corrupt because it can't be opened. But basically, if you have a Wi-Fi.txt text file on the root directory of your SD card, you can put in there your SSID and your password for your wireless network, and this card will emulate an NE2000 ISA network card. So you can basically get proper networking on a PC XT using this. So I obviously haven't got this set up correctly, so I can't show you that just at the moment, but I'll show you that in a bit. Next we have our joystick options. So basically again, that's because this is all software controlled, because we're running a microprocessor, not physical chips for dedicated jobs, we can actually add features. And when I say we, I'm in FreddyV. And in this case, we've got joystick control. If you have a micro SD on-the-go cable, you can then plug in a regular USB mouse or joystick, and it will appear as a standard game port joystick in your PC. Now I haven't tried that, so we're going to try that live in this video. So there we go. So this is the pseudo BIOS that comes with the card. Very impressive. So it's telling us what's going on here. It tells us I can't configure the Wi-Fi correctly. It's telling us that we've added an extra 128K of RAM, and the expanded memory is up and running on 268. We've got 2 hard drives emulated. Okay. Now at this point, if we press A or B, A allows us to actually boot off the physical hard drive that's in the machine, not the image that's on the card. Okay. B, I don't think is working at the moment. I think that's part of that ROM functionality that isn't quite working. We've booted off HDD0, so we've booted off that emulated C drive. I've got some features installed on my autoexec.bat, which is what this is about, and I'll show you those in a minute. But basically, you can see here we've got a C prompt. If I do a directory, this is the content of my C drive. it's calculating the free space. You see that took a while. So that's the problem with having large partitions on an XT. The machines just aren't fast enough to count them up. So 200, 300, 400 megabytes is probably the largest partition you're going to want to use. But don't forget you can have 4 separate hard disks on this system. So I'll show you that now. We'll just go straight to D. And I've got a load of apps on D waiting to be installed. So I've gone back to the C drive, and this is my C drive. Now half of these are folders that were on the original image from FreddyV, and some of them are stuff I've added. We're going to cover them a little bit, but just to show you what version of DOS we're running with, DOS 3.31. Okay, we've got our standard DOS directory. Okay. Okay, we've got a special PicoMEM folder here, and this is where a lot of the useful stuff is. So there's a test program, there's a README, there's the mouse emulator, so if you're going to use a USB mouse, that's what you use. There's the PM2000, which is the network card driver, and then PMEMM is the expanded memory driver. So those come as default on the image. If we run PM test, it tells us about it. So it tells us it's all set up okay, there's no problems. It's doing a few little tests now. So doing a whole series of memory tests at different parts of the address space. Some are read, some are write.
2 hours later.
So the RAM test actually took quite a long time, so I've edited that out. But if you've got a problem with your card and you need to get some diagnostics, that utility is pretty comprehensive about looking through memory, looking for memory problems and input-output problems. So we can't use the PM2000 drive just at the moment because we haven't got the Wi-Fi set up correctly. PM emulator for expanded memory. We should be able to look at that in a moment. What does... I don't think we've got mem... no. Okay, interesting. So the PM test has actually now caused DOS to crash. Yeah, so I can't run any programs now. So let's just quickly reboot. So we're not going to enter setup this time, we're just going to let it boot normally. Okay, so what else can I show you? Okay, so I'm just trying to check a disk to get the memory information, but actually it looks like there are some problems with this card. I may have shut it down without waiting for the writes to finish. But what it shows here is that I've got 640K of conventional memory in a machine that's only supposed to have 512. And I definitely have not got any extra chips on the motherboard. This is purely just working from the PicoMEM. So also on here is a directory that comes in the standard image called diagnostics. And in here you've got a few things. So we've got Norton Commander, one of my favorite utilities, Checkit3, Topbench, sysinfo, and Speed version 6 and PCT. I can't remember what PCT is. So should we have a look? Oh, it's PC Tools, isn't it? So you've got PC Tools in here, so let's just run PC Tools. Haven't run that for a little while. It's in French, so I'm not going to run that. I can guess where FreddyV's from, based on a few interactions I had with him. It doesn't surprise me this is in French, so we don't need to look at PC Tools. Let's have a look at Speed 600. So I think from memory this has got a very slow video card. The Paradise chipset in here just It had some really cool features in terms of extra memory, but in terms of, let's just turn the volume down. But in terms of, yeah, like characters per second, 238. So it wasn't a great text display speed. There's no floating point in unit in here because I haven't got an 8087, but it's got a CPU and it thinks it's running at 8 megahertz, which is correct, and it's benchmarking it as close to a 5 megahertz AT, which isn't bad actually. So this is from version 4.5, so it's the text-only version. It's recognised it as a NEC APC rather than a generic or an Amstrad, which is interesting. It's got the DOS version correct and it's identified the processor correct. It's got color graphics, as we know, so that's all good. It's found the 4 drives. And then memory, 640K of main memory. Okay, it reckons it's 1.9 times the speed of a standard IBM PC XT, which is good because that would be 4.77 megahertz, and this is 8 megahertz, so that's pretty much good. If we run the same command but specify a hard drive, it will also work out the drive speed for us. So as I said, I've got a particularly slow SD card in here, so it's going to give a relatively low number, but it's going to be pretty good by standards of the time. So it reckons it's 3 times faster than a standard XT would have been at the time. Okay. So all of these actually come on the standard image that PicoMEM supplies. So if you want to play with these, you can. Norm Commander is a great little 2-pane file viewer. Extremely good if you can remember all the function keys. So what else is on the PicoMEM standard image? DOS drivers. So I've added a couple of things in here. So I've added mouse and NVR. Those are Amstrad PC specific. To be able to get the Amstrad mouse with its special interface working, you need that Amstrad mouse driver. NVR lets you go into the equivalent of what should have been the CMOS. So basically we've got some other functions here that allow you to make the best use of DOS when you've got PicoMEM running. There's a disk test tool. I haven't used that. Should we try that? So it looks like it's just a speed tester rather than a utility. And it won't let me escape, so we're going to have to run it. So this test is finished. It took probably 2 minutes to run actually. It was quite significant, but it's given us the write speeds of 431k a second and read of 541k a second. Very decent for the time. Now the other utility that's in here is PM init. Okay, and this is going to have more functions in the future, but at the moment it has one very significant function which I'm about to show you. So we are currently on the C drive. But say we wanted to look at the A drive. So what I've done is I've gone to the A drive, and because there's nothing in there, it's giving an error. But if I put a floppy drive in there, you better see it's working. So we can still access the hardware. Okay. But if I load an image into PicoMEM, a disk image, a floppy disk image specifically, A drive won't be working, it'll go straight to the virtual drive. But if you can only load floppy images from the BIOS, or the pseudo BIOS, that's going to be a bit of a drag. So is there a way from doing it within DOS? Yes, there is. So the PM init allows you to have this pop-up appear where you can select your floppy disk images from within DOS itself. So there's no disk image loaded at the moment. Let's load laplink 2. Okay, so let's just, so if we go now back to A and do a dir, so we're not accessing the physical hard drive, we're now accessing the image, okay, and we've got laplink 2 binaries here on that disk image. Okay, say I don't want that, I just press Ctrl F2 again, and I can choose anything else from 2 pages. Okay, now there is a 2-page limit, which means there's 32 files. You can have more than 32 floppy disk images on the SD card, but the first 32 are only going to show using this function. But 32 is probably going to be enough for most things. So for example, if you look at WordPerfect here. WordPerfect takes 6 floppy disks, and having to be able to access those and change them in the virtual drive from within DOS is an amazing achievement and extremely useful, particularly if you have these multi-disk images. So for example, here I've got Windows 2, okay, and I'm about to try and install that on this system using this virtual floppy disk changer that I can do from within DOS. And I'm going to see if it works from within the installer as well, because I haven't tried that yet. So drive A is now Windows 2.03, and hopefully in here somewhere is a setup file. There is not. No, so maybe I have labeled these wrong. Oh, no, I chose disk 2 by mistake. Let's choose Windows 2.03, disk 1. And here we go, we've got the proper setup. I've never tried installing Windows 2 on here, so I don't even know if it's going to work. So we're going to install it onto the hard disk. We're going to call it a folder called Windows. Imagine seeing that for the first time. So we've got PC with no, VGA no, CGA yes. But we've got the special Amstrad mouse, which is detected, which is very good. Now this particular chipset that's in this Amstrad has a special color mode at 640 by 200. Windows itself doesn't have the driver, but we can download the driver to it. But let's just install it. Just checking that, yeah, no. So we'll just use the integrated. It's a British keyboard. It's the Amstrad mouse. And we're going to go for it. So it's copying files. So at some point it's going to ask for disk number 2. PIF files. If you're from Windows 2 or 3 era, you'll know what exactly a PIF file is. So it's asking us for the second drive. Now, is it going to work? Yes, brilliant. So here we can choose disk number 2, and it's working. Brilliant. So that overlay works not only at the DOS prompt, but also from within DOS-based text installers. That is amazingly useful. So I'm not going to record the whole of installing Windows 2 onto this XT, but I'll come back to the end. So one thing you are limited to is, of course, DOS file naming convention. So you're only allowed 8.3 file names. So it's asking for the font disk. Now I don't know which one that is. I think it's presumably the next one. Let's find out. Nope. Yeah, so that works. So as long as the installer's happy correcting for errors, it doesn't matter which floppy you install into the disk. Okay, so we installed Windows and it took 3 minutes tops. So in fact, we're ready to go. I do love that merging Microsoft logo, particularly on CGA, because you can see the individual lines. It just looks so cool. So on this graphical screen, I've just tried the same keyboard combination to get the floppy disk image chooser, and it hasn't come up, so that's obviously only going to work in text-based applications. So this boot chooser, this floppy disk image chooser, is a godsend. And the fact that you can choose between 320, 360k images, 144, 720, and presumably 1.2 as well, that's very flexible. So we've covered PicoMEM. So what also is on here is, where did I see it? Prints. So many of you have already guessed what that is. That's going to be Prince of Persia. Now, the reason that's on here, I think, is because that does support the AdLib sound card. So what we're going to do is plug in some speakers and see if we can get any sound out of this PicoMEM. So how about that? AdLib sound from the PicoMEM, completely software defined, no sound card in this machine. So I'm just going to turn the volume up on the PC because the sound effects come out of the PC speaker and the audio comes out of the sound card. So yeah, so how about that? AdLib audio off a software-defined card, single slot solution with all those other features as well. That's pretty damn impressive. And we haven't even touched on the Wi-Fi networking yet. Now I was saying that this sound card was very noisy, but what I've done is change the cable for a mono one, and the noise has pretty much gone away. So I was using a stereo 3.5mm jack cable. I've changed it for a mono one, and that has completely eliminated the noise. So it's not a problem with the card, but if you're going to be using this, perhaps use a mono cable. So let's see if we can get the Wi-Fi working, because that would just be the icing on the cake for this particular card. Okay, networking. In networking, we've turned networking on. So this is off by default. You have to select a port. So 300 IQ3 seems to work. And I've also got USB host on for explaining about how joystick and mice work in a bit. So let's just boot. So I've updated my Wi-Fi .text on the SD card. And if you look now, my Wi-Fi is connected and a reasonable signal strength, but I am only about 4 feet from the router. So one of the problems, because the Wi-Fi chip does not have an antenna, and because it's inside your PC, the range that it can detect signal is pretty low. With an Amstrad PC like this, with a plastic case, you have a massive advantage. If you had a big IBM 5150 with a solid metal case, the signal's not going to get through very easily. But in this case, we've got a very good signal. So I've also turned on the EMS function, and we're loading the PicoMEM driver. I've got it with a /n command line argument, so it doesn't check the memory, but we've got 255 pages of EMS, gives us 4 megabytes in total. Let's have a look at how the networking works. So in the PicoMEM directory, there is a file called PM2000, and that's a novel NE2000 driver kind of substitute. Okay, so the PicoMEM has been detected. It's detected that we're using port 300 as set in the pseudo BIOS, and interrupt 3 as set in the pseudo BIOS. This is the MAC address of the pseudo card. So we have the card driver installed in DOS. We have a Wi-Fi connection to the router, but we don't have a TCP stack yet on this computer. So luckily, FreddyV has already included MTCP, which is a whole suite of DOS-based TCP programs. So the first we need to do is a DHCP, because we need an address on the network. So it's sending a DHCP request, and we receive one. So it's given us the IP address of 192.168.0.102. So brilliant. So that means we're now got an IP address on the network. We can now do IP stuff. So the obvious thing to try is pinging something. Let's ping a very obvious number. And there we go. So basically, we now have IP working on this XT class machine from 1987, and we just pinged the Google server on the internet. What can we do? What can we do is actually useful? Well, one thing we can do is FTP. Okay, so there is an FTP client on here. So for example, if we FTP to an actual FTP public site, this should work. There we go. So we've attached to the University of Kent's mirror service. Some of you may be familiar with that from downloading ISOs for various Linux distributions. So we need to log in. So You need to type in the correct username, which in this case is anonymous, and then we're in. So we can now access the FTP server as if it was kind of local. So if we go so these are all the mirrored sites we have access to. So if there was something in here that was relevant for DOS, we could actually just go to that directory and download a file directly onto this XT using IP over the internet using the Wi-Fi. Absolutely brilliant. As long as you can boot to DOS and get the driver loaded into memory, you can then potentially start downloading stuff directly from any FTP server that you have access to. So whether that's a public one like this or your own setup where you've got your own drivers and images for programs that you can download onto your virtual hard disk. Brilliant. So that's networking. Networking does work. Got Telnet, of course. There's microweb, which I believe is a web server, so you could actually serve HTML from your PCXT. Not going to do that today. That's networking. Let's try something else. So the other thing that's in this directory, PicoMEM, is PM mouse. So if you've got a USB on-the-go cable or adapter, you can plug that into the PicoMEM, and then you can plug USB devices into that. And the currently supported devices are mice and joysticks. What I've got here is a generic laser no-name mouse plugged in. The laser light is on, which means it's receiving power from the PicoMEM. And if we do something like looking Norton Commander, without a mouse driver loading, there's no mouse cursor, the mouse doesn't work. But if we load, and then do the same thing again, you now have a mouse cursor here in the middle of the screen, and it moves around, and the responsiveness is brilliant. It's massively better than the Amstrad mouse resolution and polling frequency. To get the cursor from one side of the screen to the other with this, even set a maximum sensitivity without NVR, you know, it takes about 3 scrolls across the desk. With my little laser, I can do it in a couple of inches. If you have some use of a pointer, for example, if you're using Microsoft Windows or GEM, then possibly using the USB mouse functionality is going to be a bit of a lifesaver for you, particularly as these Amstrad mice are now very hard to get hold of and quite expensive, whereas any generic USB mouse will work. As far as I can tell, I can't get mouse support and joystick support to work at the same time. And I'm not sure if that's just because I'm not doing it properly, or whether that's because that's the way it is currently with the drivers of the situation as they are. But let's see if we can get a USB controller working. So I've unplugged the mouse and I've plugged in a joystick, which I'll show you in a second. We're going to reboot and we're going to enable joystick support. So we go back into the pseudo BIOS, come down here, USB joystick support needs to be on. If that's on, the mouse port doesn't seem to work. So you need to turn that off if you want mouse. I don't think you can have both working at the same time, but if someone knows different, please let me know. The BIOS I'm using is version 0.4, and that was from the 8th of July this year. So it's a very modern, up-to-date BIOS. I think it's the most up-to-date one. So let's reboot. Okay, now for the joystick, in theory you don't need any drivers. So if we go to prints, and see if we can get prints running. So what I've done, I've plugged in my PlayStation 4 controller, which is allegedly one of the supported ones. It's plugged in with its USB cable. It's receiving power. So here we go. I'm using my controller here to move the good old character around. So there you have it, joystick support. So as I said, I don't think you can have mouse and joystick support working at the same time, and it requires a reboot to switch between them. I'm guessing that might be improved in a future update. I don't know for certain, but it definitely works. And if you're a gamer and you're interested in using a fairly modern gamepad that's USB based, with your retro games, then the PicoMEM lets you do that too. Let me just quickly show you that 4 megabytes of EMS memory. So if we go to Norton System Info, everything here is the same, but we've got 640k of memory using that 128k memory expansion, but we also have 4 megabytes of expanded memory. Now this is going to be slow in terms of RAM. It's not going to be as fast as that extra 128k, but if you're using a spreadsheet and it requires expanded memory, then you have that function. That's definitely not going to be a problem. And 4 megabytes is a very healthy amount of memory for 1987. Now, what I can't do with this version of DOS that's running, version DOS 3.3, is I can't use any of that upper memory area for DOS itself. We don't have the load high command available, and so we need a later version of DOS to be able to access that. So we do have 578k of memory available, so that's pretty decent, and we could probably trim that a little bit with careful use of the drivers. But if we had a later version of DOS and we enabled filling in that top bit of memory, we could probably load some of these high, and we could probably get, you know, probably 620, 630 megabytes of conventional memory available. And there's our EMS. It's being recognized as LIM version 4, which is the last version they made. So there you have it, the PicoMEM. Possibly the single most useful add-in to any PC XT class machine. This will also work in 286 and 386 machines to some degree, and there is a list of tested machines on FreddyV's GitHub page, along with some machines that are known not to work. I'm looking at my Amstrad ALT286 thinking this is a genius card for that. Doesn't matter if the hard drive is broken, doesn't matter if the floppy drive is broken, I can add some sound. What a great little card for that machine as well. So far I haven't really found anything wrong with this card. It's done everything I've asked of it, it's done more than I was expecting, and the one thing we haven't talked about is the price. So for all this functionality, to replace things like the IDE XT, the EMS memory cards, an AdLib compatible sound card, to add all those functions separate cards is over £100 easily, and you're probably heading more towards 150. I picked up this for 62 UK pounds, and that included the extra audio units pre-soldered and included delivery. So this is an absolute bargain. Not only does it work really well, it's actually very reasonably priced. And the beauty of that is the software control card. Because the component cost is low, it can be made relatively cheaply. So thank you FreddyV for making an amazing device. Hope you found this review useful. I'll give an update should new features be added, and if you know how to get the mouse and a joystick working at the same time, please let me know. I'd be very interested in getting that done. We'll see you in the next video from some more shenanigans. Didn't really say that.